In this tutorial, we will cover how to use the SMOTE node. SMOTE is a technique for synthetically creating new data points to balance a smaller class. This is a powerful technique for creating a more representative dataset and boosting performance of classification tasks. Here in this workflow, I have also added a few additional nodes, including the cast to single type and columns cardinality, to check our work. An important note before adding the SMOTE node is that you will require a vector assembler. As with many of the modeling nodes in SparkML, a vector assembler is required to assemble your features into a vector before conducting additional analysis. Here in the SMOTE node configuration pane, the first thing we need to select is our label column. In this case, for future classification tasks, we want to predict the class. Next, we need to select our features column. You will notice there is only one option, and it is the vector that we created using the vector assembler. We can also change the bucket length here if we feel it is appropriate. The additional nodes after the SMOTE node are the same as the ones before it. They are simply to check our work. Now we can execute this workflow. Here in the execution page, we can see that first we have our columns cardinality node. This shows us the count of each of the classes that are available in our dataset. We can see that the largest classes have about 70 values in them, while other classes only have 16, 11, and 9. We also have one class here that has only 3 values in it. This will become important later. Ideally, for a classification task, if we want to predict it, for example, class 5 here, we only have 11 data points to build our model off of. This will usually result in poor performance. We ideally want each of our classes to have an equivalent number of values. After our SMOTE node executes, we can see that in the dataset, we have a new features vector column. These are the vectors that have been created by the vector assembler and that represent our features node. Additionally, you can see that there are blank spots here in the other columns that are not the features vector or our class column. This is because when the SMOTE node creates new features, it only creates them in the features vector. It does not populate the rest of the dataset with these values. After we execute the SMOTE node, we again have a columns cardinality node. Here we have the same classes, and as you can see, almost all of the classes now contain 70 values. This is ideal for classification tasks. The only issue we have here remaining is that class 7 still only has 9 values. This is because it only started with 3 values, and the SMOTE node will struggle to extrapolate based on a very few number of data points. Ideally, we need a minimum set of data points in order to use the SMOTE node. In this case, that was not satisfied, so we are left with only 9 values. Thank you for listening.